Okay, again, Assalamualaikum. Very good morning to all students. So, today is our discussion regarding the task of last semester, not last semester, last week, okay, under the chapter number system here. Okay, so last week, a lot of people WhatsApp me and asked me a lot of questions, and I told them to wait until this week so that we can discuss this with your friends, okay, with everybody else. So, okay, so since most of you is currently doing the lab assignment here, okay, so today I will discuss to you about the way you can do and conduct the lab assessment. And I think last time, okay, based on the chapter I insert, the lab sheet that I inserted inside the Google Classroom, okay, wow, inside the Google Classroom, still 3 sections, 74 people, okay. Okay, so in Google Classroom, I think I put a little bit wrong settings in the document where I allow students to edit. So some of you, when you open first time, it is empty, and second time you open, it's already filled in. Okay, some of you already filled in inside it and didn't submit. So please check again. Okay, I have changed the setting. So please take a look at the file again, download and re-upload when you submit. Don't fix it inside the document inside the Google Classroom. Okay, I disable the editing by the students. So you have to download and re-upload again when you want to submit. Okay. So, okay. So now, okay, today I will discuss to you about how you are going to do the lab for the chapter 2. Okay. So I will not discuss entirely everything. I will not discuss entirely all the questions, but it's just good enough for you to understand how we do it. Okay. So start with this chapter here. Okay, number system lab module. So in this lab chapter, okay, for 2.1, okay, understanding the use of number system. So here I have an ASCII table. I provide to you an ASCII table here. Okay, so the ASCII table here is representing the binary and the characters of your keyboard. Okay, the binary and your characters of your keyboard. Okay, so here, okay, I gave you hexadecimal digits. Okay, so they are in pairs. 44722E20. Okay, hexadecimal is the red one. Okay, so hexadecimal, okay, is the red one. So 44 is over here. Okay, it start with D. Okay, in this case, this D. Okay, so and then 72 is somewhere here, is R, small r. Okay, okay, so for 72 is small r. Okay, and then 2E is somewhere here, 2 and E. So it's dot. So I need you to find all the uh, codes. Okay, the one that I've give here is hexadecimal, so it's based on the red one. Okay, so you need to convert it into the character of your keyboard code. So based on the rightmost column. Okay, so use the second column to convert the into the rightmost column. Okay, so next one. Okay, okay, next one, you are given this rightmost column. Okay, you are given the rightmost column, and I want you to convert all of them into hexadecimal and binary. So you need to convert them into hexadecimal and binary here. Note that space also count as one hexadecimal. Okay, if you see here, there are space. You need to find here inside this, where does it represent space? Okay, where does it represent space? So in this case, if you look at the codes, okay, space, space, space. I think somewhere here. Let's open up in a clearer slide. Okay. Okay. So if you see here, space is 20 in hexadecimal, 1000000 in binary. So this one is the space. Okay, so all the space, comma, okay, okay, they have their own hexadecimal representing them. So you need to make sure you focus on the ASCII. Okay, don't just blindly convert all the alphabets only. The symbols like comma and also the space also require you to follow the hexadecimal as well. Okay, okay, you understand? No problem? No response?
No problem,
Yes,
sir.
sir.
Okay, good. Okay, next. Okay, so let's try and convert this table here. Okay, so I'll try to demonstrate to you. Okay, this top line only. Use the knowledge that you have, okay, for the top line to convert the rest. Okay, so let's try this. Okay, new tools not that good. Okay, you have 76.529. 76.529 here. Okay. Okay, so this one is in decimal, so I usually type D at the end. So how it's exactly I want to convert to binary. So firstly, okay, you need to write on the left. Okay, you have 2, 4, 8, 16, 32, 64, and 127, 128. Okay, and then on top of here, so you have 0, and you have 1, sorry. Okay, so and then you have 0.5, which is 1 divided by 2 is 0.5, and then you have 0.25, which is 0.5 divided by 2 is 0.25, and then you have 0.125. Okay, 125, which is the division of 0.25. Okay, and you can go even further, 0.6 625, 0.0625. So it's another half. Okay, so this one is representing by 2 power. Okay, let's start with 1 here. This one is 2 power of 1, 2 power of 0 here. Okay, so in this case, wait, 2 power of 1. Okay, just look at the top here. Okay, so here is 2 power of 0. This is negative 1. This one is negative 2. This one is negative 3. This one is negative 4. Okay, here is power of 1, 2, 3, 4, 5, 6. Okay, 7. Okay, so here, if you look at here, if you talk about 8 bits, okay, let's insert some tables. Okay, you have 8-bit. In this case, 8-bit. No shading, and border is black. Okay, good. So you have 8-bit. So on top of here, okay, so here is depends on the number that you have. Okay, in case you are assigned to convert 8 bits binary, so you have to use 8-bit. Okay, it doesn't matter, they just start at -4 and end as 3. Okay, it start with 0 and as 7. It depends on the numbers that you need to do. Okay, so in this case, I didn't mention any number, like for example 8-bit or 4-bit. Okay, so this means that you are free to use however many bits that you want. Okay, so in case you are free, okay, you can start by figuring out what kind of number do you need. Okay, so first, this is the way that I used to do. Okay, 76.5, 76 here, you separate 76 here, 1, and then you separate 0.529 here. So you have 2. Okay, you separate into 2. Okay, so 76, firstly, okay, you need to subtract, you need to find the closest power of 2 to 76. So closest power of 2 to 76 is 64. So you have this minus 64, okay, which is equal to 12, okay, which is equal to 12, okay, and then find the next closest power of 2, okay, next closest power of 2, which is closest power of 2 to 12 is 8, subtract with 8, okay, and then you get, then you get 4. And then next, subtract with next closest power of 2, which is 4. You subtract with 4, and you got 0. Okay, so look back here, you have, in this place is 2 power of 6. This place is 2 power of 6. This one 2 power of 6. This one is 2 power of 3. Okay, this one is 2 power of 2. Okay, so then next we have 0.529. Okay, use the same concept. Okay, however, we use with the negative one. Okay, so start with 0.529. Okay, you subtract with the closest power of 2 is 0.5. Okay, the closest power of 2 is 0.5. So which is, you got balance of 0.29. Okay, 0.029, sorry, 0.029. So next, okay, subtract with the next closest power of 2. What is it? So this one is kind of difficult for you to find. So let's try and do again a little bit more further. Okay. So 2 power of -5 is 0.0625 divided by 2. So 0.0625 divided by 2 is, okay, 0.03125. Ah, so is it good enough to subtract? No, you cannot. So you need to find the next closest one, 2 power of 6. Okay, which is 0.3125 divided by 2, which is 0.015625. 15625. Okay, so if you subtract this with, okay, subtract this with 0.015625. Okay, if you count it again, you'll get the remaining equal to 0.013375. Okay, so this one is 2 power of -1, and down here is 2 power of -6. Okay, so because it is too small, okay, let's stop here. We don't have that many bits to handle everything. Now it's already more than 12. So in this case, okay, so let's create a table, okay, which can fulfill all. Okay, it's a table here, number of columns, let's make it 12. Okay, so this one is start with 2 power of 6. Okay, power of 6, power of 6, power of -6, sorry, -6, 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. Okay, so here is power of 0, and here is 1, power of 1, power of 2, power of 3, power of 4, power of 5. Oh, not enough. We need another one. Power of 6. Okay, so you have, okay, this number. So when you see, okay, you draw everything here 0 first. And look at the binary that you have calculated here. So those that have the values minus here, you change it into 1. So you have power of 6 here is 1. Then you have the power of 3 here is 1, and power of 2 here is 1. Okay, and then here supposedly, okay, you need to insert, okay, here a dot. Okay, point. Okay, so it's going to be like this.
So you didn't get to change the power of 2.
I didn't get, oh, power of 2 I missed. Okay, thank you. Okay, so here you put in dot, and then -1 and -6. Okay, so in this case you already got the binary here. Okay, so should be no problem, right? So whatever you do, you need to remember there are 3 steps involved. Okay, so the first step is to draw this table. Okay, this is the first step. First step. Okay, draw this table here. Okay, you draw this table here, and then the second step is to subtract, to separate first. Okay, you have okay, and then third step is subtract. Okay, subtract. Okay, and then the final step is align. Okay, so here you can get the binary. So start with here, you draw this one first, okay, up until 2 power of 7, and up until you estimate how far you could go. Okay, in this case, it can be up until 2 power of 6, okay. And then if it's even more further, it become insignificant anymore. So that's why usually, okay, in your exam or assessment, I say that please limit the answer to 3 decimal points. So means that you go up until 3 points only. Okay, should be no problem in that. Okay, so okay, so this is where you got the binary. So this is the binary. Okay, so and then in case you want to get the hexadecimal and octal, okay, in case you want to get the hexadecimal and octal, how can you get the hexadecimal and octal? So in case of hexadecimal, you need to separate it into 4. Okay, so let's use this one, this color. I use blue color. Okay, wait. Okay, so separate them into 4. Okay, okay, sorry. So in this case, okay, you need to make sure that when you separate them into 4, you separate them from the point 4. So this is 4-bit and this is 4-bit. So because we have one extra, not enough here, you draw another one and put 0 here to complete them. Okay, so in this case, you have here is 4-bit. And 4-bit. Okay, and then to the right, okay, in this case 4-bit from the this point into this point, and then you need to put up until 4-bit more. So at the end here we have, so in this case when you convert it into hexadecimal, just convert this value according to the hexadecimal value. You have from, okay, hexadecimal you have from, okay, let's create this in another slide. Is it easier for you to see? Okay, so when you convert them, okay, you need to have a binary hexadecimal table, okay, with you. So let's just try and draw a hexadecimal first. Okay, so draw the binary first, 4-bit binary, 0, 0, 0, 0, start with 0, 0, 0, and then continue with 0, 0, 1. Okay, because it doesn't have 2 until 9, so after 1 is 1, 0. Okay, and then after 1, 0, you got 1, 1. Okay, it doesn't have 12, continue with 12 until 99 we don't have, so we have 1, 0, 0. And then we have 0, 1, 0, 1. Okay, and then we have 0, 1, 1, 0. And then we have 0, 1, 1, 1. And then after this we have 1000. Okay, so you have continue again 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 0, 0. Okay, continue next. So I'll make this one smaller. Okay, so let's make another table here. So here is 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. Okay, so here is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, next is 13, 14, 15. Okay, so you know that we don't have 10 until 12 until 15, so this one is A, B, C, D, E, F. Okay, so you have this table here, so it should guide you to complete the list above. Okay, so you have here on the top, or from the, let's start from the left here, 0, 1, 0, 0. So 0, 1, 0, 0 is 4. So in this case, you have this as 4. Okay, and then you have 1, 1, 0, 0. 1, 1, 0, 0 is C. And then you have, in this case, 1, 0, 0, 0 is 4 again. Anyways, no, not 4, it's 8. And then finally 0, 1, 0, 0. 0, 1, 0, 0 is 4. So your answer is basically 4C dot 8 for hexadecimal. Hexadecimal we usually use H. Okay, so this is the answer for your question. Okay, so this one is simple case for conversion. So this one, okay, so for binary, convert to binary. So I'll remove this one, so it's easier for you to, you can use this slide later. Okay, so this one are all for binaries. Decimal to binary. Okay, so converting decimal to binary, you need to subtract a lot of things and then align again. Okay, according to the bit. But however, from binary to hexadecimal, you just split the bits. Okay, so and then from binary to octal. Okay, I like using binary from binary because it's easier. Okay, so from binary to octal. So binary to octal is almost the same as hexadecimal. The difference is that instead of 4 bits, you need to use 3 bits. So 3 bits. So from the top here, from the point, middle point here, go towards the left first, 3 bits. Okay, and then from here towards the left, okay, 3 bits again. Okay, you see that we have some extra. Okay, and then this one you don't need to put in the one at the right. So you need to put in this one. Okay, so you have to include another one. Yeah. 3 bits. Okay, this one. Area. So this one, okay, make it another 0. Okay, 3 bits, 3 bits. Okay, good. So in case of octal, you only have 3 bits, so you have only up until 7. Okay, so here, delete 1, delete, delete. Okay, 7. So when we look at this, okay, start from here, 100 is 4. Okay, 001 is 1. Okay, 001 is also 1. 100 is 4. Okay, 001 is 1. So you got your answer here, 114.41. Oh, because it's an octal. Okay, so in this case, you look at, okay, you just separate them into 3 bits. Okay, when you want to convert it again from octal to binary, for example, you just create something like this. You line it again, 3 bits. Okay, alignment 001 is here, and then 001, 100 is here, 001 is here, 001 is here. So you can align it again to your binary. Okay, when you want to calculate the decimal, okay, you have your binary aligned here, and then you just add again. This one, like for example, in this case, 64 plus 8 plus 4, you got 76. And in this case, 0.5 plus 0.015625, you got 0.515625. Okay, and then you combine back together, you got 76.015, 0.515625. Okay, so same as hexadecimal, when you want to convert it into bits, okay, you just select, you can draw this, write this table, this list first, and then convert it 4 bits by 4 bits. Okay, you need to remember there are middle point here. Okay, from the point towards the left is the real number. Okay, from the point towards the right is the fraction number. So it's not that difficult for you to fill in. So in this case, okay, for the binary here, you got, here is 10011. 10011 00 00 0.1 2 0 0 0 0 1 2 3 4 5 6 okay 1. Okay, so okay, so we got this binary here. For octal, in this case is 114.41. This case 114.41. Okay, and then in hexadecimal you have 4C84H, 4C84, 84. Okay. Okay. Not changing. Okay, 4C84. So please use the same techniques that I've shown you to complete the rest. Okay, you can write like this. Okay, in your PowerPoint if you want to. It depends on you guys of how you do it. Okay, so make sure you complete all of them by tomorrow. Okay. So next is the different number representation for 8-bit system. Okay, you have sine magnitude, 1's complement and 2's complement. Okay, so let's take a look how you're going to do this. Okay, it's the same thing as what you did for converting binary. Okay, you have copy this table. No, copy. Okay, then you have this list. Not copying it. Okay, so you have 19. Okay, use the same concept as you got here. So for 19, convert them into sine magnitude. Okay, so in this case, you have 8-bit system. You don't need to have a lot. So this one, I think most of them are real number. So you can remove the remaining points. Okay, and then you add the column that you need. Okay, so here is up until power of 7. My keyboard is not working. Okay, power of 7. So here in this case, okay, let's start everything from 0. Okay, so as you can see here, I have 8-bit. Okay, so I want to calculate 19. So let's calculate 19. Okay, 19. So the closest power of 2 here is 16. So subtract with 16. Okay, you got balance of 3. The next closest power of 2 here is 2. Subtract with 2. You got the remaining is 1. Okay, the next closest power of 2 here is 1, which is subtract with 1. You got 0. And then finish. So in this case here, what you got is, so here is 2 power of 4. Okay, here is 2 power of 2. Okay, and then here is 2 power of 0. And this here 2 power of 1. Sorry, this one 2 power of 1. And here is 2 power of 0. Okay, 2 power of 0. Okay, so when you got 2 power of 0, okay, you got 1. So this one is 2 power of 0, this one is 2 power of 2, and then this one is 2 power of 4. So look back into your table here. 2 power of 4 is, okay, convert to 1. 2 power of 1. and 2 power of 0. So you got here for sine magnitude, okay, sine magnitude, you need to remember that on the leftmost bit, it should be converted into sine. So which is either positive or negative. So in this case, okay, still, okay, in this case, okay, you got positive 19. So positive usually will remain as 0. And other than that is 0, 0, 0, 1, 0, 0, 1, 1. So you got the answer here. Okay, 0, 0, 0, 1, 1. Wait, again. 0, 0, 1, 0, 0. 1, 0, 0, 1, 1. So finish off your first sine magnitude. Okay, this is in case for sine magnitude. Okay. So for 1's complement, okay, 1's complement, because 1's complements and also 2's complement, because they are particularly different in only negative numbers, okay, so basically you don't have to change anything, the same thing, okay, same thing. So only that 1's complement here, in case of 1's complement, okay, in case of 1's complement, you have this power of 7, power of 7. Oh no, this one is also for sine. No, power of 7. What's complement? Okay, power. Let's just remain it as power of 7. Okay, 1's complement and 2's complement. So it's the same thing. Okay, and 2's complement. Okay, so this is for question number 1, which is all of them are positive number. Okay, in case for question number 2, okay, which is all of them is a negative number. Okay, so here, okay, you have the question for number 1 here, you have the question is negative 19. 19, huh? So in case of 19. So in this case, we have 23. 23, negative 23. So firstly, before you do the negative 23, you need to do the positive first, positive 23. Okay, same thing, positive 23. Okay, the closest power of 2 here is 16. Okay, where you get the balance is 7. Okay, and then you get next one is 2 power of 2, which is you got the balance is 4. Remaining is 3. And then 2 power of 1. Okay, 2 power of 2. Remaining is 1. Okay, so a little bit further. And then you got down here. Okay, subtract with 1, where you got 0. So you have here is another 2 power of 0. Okay, change everything back to 0 first on your table. So this one is 0, this one is 0, 0. Change everything to 0 first. So this one, to avoid confusion, change everything to 0 first. Okay, so then, okay, choose based on the one that you subtracted. Okay, so here you have 2 power of 4, 1, 2 power of 2, 1, to the power of 1, 1, power of 0, 1. Okay. And then because it's a this one is a for positive. Okay, in case it's a negative number, okay. Too big. In case a negative number, you just change this into 1. And you got the answer for sign magnitude representation. So it's 1, 0, 0, 1, 0, 1, 1, 1. Okay, 1, 0, 0, 1, 0, 1, 1, 1. Okay, so next, how do you convert it into one's complement? Okay, so in order to convert into one's complement, okay, let's draw, okay, one insert rows above. Okay, so the original binary for okay, so this one is 23, this one negative 23. Okay, so the original binary for 23 is okay, this one. Okay, and then when you want to convert it to one's complement, you just swap the 0 to 1 and the 1 to 0. So in this case, 1, 1, 1, 0, 1, okay, 0, 0, 0. So you just switch the 0 to 1 and 1 to 0. So you got the negative numbers for one's complement. Okay, it's easy, right? Okay, so this one is one's complement. Okay, so you just, okay, let me make a note here. Change the ones to 0 and 0 to 1. Okay, so it's just as simple as this. Okay, now for the 2's complement, okay, just one more step further. Okay, you got the 1's complement here. Okay, insert plus 1. Plus 1, 2, 3, 4, 5, 6, 7, 8. Okay, plus 0, 0, 0, 0, 0, 0, 0, 0, 1. Okay, plus 0, 0, 1. Okay, so your answer for 2's complement is easy. When you add this bits to this, you got, just add another one here. Okay, and this is your 2's complement. Okay, it's easy, right? It's not that difficult. Okay, so your answer here in this case is let's just click 1, 1, 1, 0, 1, 0, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0. Okay, so in this case 1, 1, 1, 0, 1, 0, 0, 1. Okay, so finish with the second question here. Okay, so you see that, okay, what I have shown you here is the answer for the 1's complement and 2's complement conversion. So we already finished for our conversion in this case. Okay, so finally, okay, to add and the operation for adding and for 1's complement and 2's complement, okay, this one you can base on my notes online, but just in case, okay, let me do it for you. Okay, for 5 is 0, 1, 0, 1. Subtract with 2, 0, 0, 1, 0. Okay, so you got 3. Why? Okay, so in this case, 1's complement will be converted into 1, 1, 0, 1, and 0, 1, and this minus will be plus. Because it's same as plus 5 plus negative 2. Okay, so when you add everything, in this case you'll get, okay, 1 plus 1 in this case is 0, and then you go back up 1, and then you go 1, okay, and then you become 0 again, and then go back 1. Okay, so what? Wait, 1, 1, 0, 0, sorry, 0, 1. Okay, you got 1 extra at the end. Okay, you got 1 extra at the end. So this one here, okay, so we push it down. Okay, we push it down. Okay, we push it down. Okay, in the end, the answer will be the answer will be 0, 0, 0, 1, 1, which is 3. 0, 0, 0, 1, 0, 0, 1, 1. Okay, so you get the answer here. So this one, the one at the end, the extra one, will push it down. Okay, and then add it again at the back, and you will get 0, 0, 1, 1. Okay, so for 2's complement, let's take a look. So because 2's complement here is 1, 0. Okay, you add another one here. So when you add everything, okay, you got here is 1 plus, okay, first. Okay, 1 plus 0 is 1. Okay, 0 plus 1 is 1. 1 plus 1 is 0. Add another one. 1 plus 1 is 0. Okay, and then you got one extra one. Okay, so this one, you got an extra. However, this one, we doesn't count it. Okay, and this one is categorized as overflow. Okay, overflow. Okay, because we on only 4 bit. Okay, 4 bit. So this one more extra here is count as overflow. So in case you have you are doing it for 8 bit, means that the bit number 9 is count as overflow. Okay, so the rest of it you try and do it yourself. Okay, it's not that difficult. So do you have any questions so far? Please ask me anything that you want to ask. Okay, I want to close this session already. Any question? Any question?
No, sir.
No. Can you understand what I'm teaching you?
Yes.
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 Okay, do you want the slides to support the way? Do you want the slide? The
Yes.
explanation here?
Yes, sir.
Yes, sir.
Okay, okay.
Yes, sir.
Yes, sir. Yes.
Okay, so I'll upload it into the lab assignment as one example. And I will upload the recording of I'm doing this online in YouTube again. So you can refer it back later on. Okay?
Okay.
Okay, sir.
Okay,
Okay,
so
sir.
it's 10 o'clock already. I have another meeting. So I'll see you guys.